Hi, my name is Paolo Zanini. I'm head of IoT and digitalization advice. Today, we're going to talk about condition monitoring. So, your machine is running, producing smoothly. Is it really? As fast as it should? Are you sure that nothing is happening under the hood which may cause an unexpected production stop? Or isn't it operating under such conditions which could void the product warranty? For instance, overload. As an engineer, you don't want to believe everything is fine. You want to know the answer to those questions. Without continuous monitoring of measurement data, it would be impossible to answer them. Condition monitoring, anomaly detection, and predictive analytics are just different levels of sensibility and automation of machine diagnostics devoted to maximize availability. We're going to talk about the first step, condition monitoring. So let's focus on continuous measurements and monitoring of limit values. Take a look at this typical indexing system. Here we have an EF3 controller and a TC150 rotary indexing table. It looks fine, clocking nicely, but it has a problem. See, I just got this email telling me something is wrong. Let's see what it says. This is an anomaly report. It's telling me that the peak current hit the set limit in the motion cycle. It says it could have even been a collision. It turns out I manipulated the motor brake circuitry, made the brake clap when it shouldn't. I did that on purpose to show our system is able to identify sudden behavior changes and warn you accordingly. See, we have a clear peak in this diagram around 3 minutes ago. Maybe it's time to ask the operator what happened and to make sure it doesn't happen again. Data collection is the basis of condition monitoring. Our dedicated indexing table controller EF3 samples relevant signals 1,000 times per second, makes some pre-processing and delivers valuable data for condition monitoring as a standard. We know our own rotary table very well and our controller, so our embedded firmware mines down there near the hardware the features we will need for powerful monitoring. So our controller does not simply offer a command interface, but also application-specific diagnostics and pre-processes signals which can be easily consumed by the machine PLC. We've put our process knowledge inside the EF3, so machine builders and operators don't have to figure out controller parameters, how to process raw data, and which limit values to use. Traditional field bus interfaces support only the traditional automation pyramid. If you want to monitor a new signal, you have to publish it in the fieldbus telegram, interpret that telegram in the PLC, then convert it to the SCADA layer, and only then send it over to the system actually needing it. But many of our products offer an OPC UA server. This way, you can simply jump over all of the layers of the classical automation pyramid, thus reading field-level data directly into your MES, ERP, or CMMS, shop floor maintenance management system. Don't touch a running system, they say. Yeah, with OPC UA, you can X-ray it, no need to touch. So far, we talked only about how valuable monitoring data is generated and how it's made available. So far, so good. But you have thousands of automation components, hundreds of vendors in your shop floor. How are you supposed to find out whether there is something wrong inside actor ZYB9044? As a matter of fact, you're not. We are the component manufacturers. That's why we offer an edge layer which is able to combine data from tens of components, monitor their states, and automatically react to relevant events. This software component composes meaningful reports and sends them per email, or directly to your plant maintenance software if you wish. Our edge layer also brings up open interfaces to data lakes and common IoT platforms. Perhaps you wish to run your edge software in your own servers on premises. That's easy done, since it's a Docker container. Or perhaps you do want to have an edge computer in your electrical panel, we can arrange that too. After all, it's still a Docker container and cannot be bothered by hardware specificities. TC, a great product with proven quality. EF3, the perfect controller with embedded feature generation. OPC UA for data freedom and flexible architecture. Vice IoT Edge for monitoring, report generation and connectivity. I would say these are the minimum requirements to sleep at night.